All right. I guess everyone is here who is interested. Let's start. So, I will talk about virtual machines on macOS, specifically on Apple Silicon machines, because they're where the performance is. And the gain, losses, differences between running it on a physical hardware in a virtual machine or in the cloud on a machine that you rent, this kind of stuff. Yeah, people who don't know me, I'm Daniel. I'm working for THEOCon, a mobile engineer, and I'm also interested in a lot of stuff. So if I have talks in the future, probably not all of them will be mobile related. So let's see. With macOS Ventura, I think, or even one version earlier, Apple introduced the virtualization framework, but right now it's a major, it's a major version. It's not beta. And basically, what the virtualization framework gives you is just a framework like UIKit or all the other iOS frameworks that you can use in your application or AVKit. And basically, it gives you high-level APIs for creating and managing virtual machines on Apple Silicon and Intel-based Mac machines also. And you can run Linux, macOS, and some people made it work with Windows, ARM Windows machines also. And it gives you this virtual I/O device interface for all the fun, to have a network interface, hard drive, socket, all these things. And to have a macOS virtual machine, the thing what you need right now is a is a Mac with the Apple Silicon chipset. So if you have an Intel Mac, you are out of luck. You cannot emulate or simulate, a virtual machine with macOS. You can still do the Linux part, that's fine, but not for macOS. And with this framework, basically, what you can do is building a virtual box. Basically, you can build the virtualization software yourself. So like Parallels Desktop, VirtualBox, and the others which are on the market. You can achieve a similar thing. Obviously not as good or as detailed as those things, because there is a lot of black magic behind, but you can have something that maybe you can reuse in the future. If you start developing an application that reacts as a virtual machine, as I mentioned, you need an M1 or M2 Mac for it. You need to put an entitlement in your application which enables the virtualization, and you need an IPSV restore image. That's the same restore image that you use when you restore your iPhone, for example, from the cloud or from a local backup. The same thing when you have the new Macs. Those are also restored from this IPSV file. And yeah, your virtual machine will be also restored and installed from this file. And you need some patience and time. I will not go into deep what is virtualization, hypervisor, all these things. I guess there are better people who can tell this instead of me. What I would like to describe here is the way how Apple supports you to do these things, and what are the benefits or disadvantages. There are really nice APIs. You don't have to do a lot of manual work to get these things running. So, for example, you said, "Oh yeah, I need an IPSV file. From where I can get it? Which one? How? What do I do? Which machine? Which platform? Whatever." There is an API from Apple called VZ macOS Restore Image. Just fetch latest supported, and this will fetch you the latest IPSV file that the machine that you are using right now supports. And obviously, this is also valid for other machines. So it's not just specific for yours. It's a generic one. And after the image location, or Apple points you to the location where to go, then you can start downloading this image with a normal iOS download mechanism, like an URL session or something. And then at the end, you have your image on your hard drive, which is around 10-ish gigabytes. After that, what you do is you set up your virtual machine, you create a virtual machine configuration, you define that the platform here is macOS. You can decide how many CPU cores you need, what's the memory size. the disk size, and then bootloader, graphics driver, all these things, you set it up. You will find this code at the end of the presentation, the next code project, so don't worry. And then after you have your machine constructed, you ask the API to validate it, and if everything goes well, you can create a virtual machine with this configuration. Once your virtual machine is there, it has nothing on it, so you have to use the IPSV file to boot up the installation. And you just load the IPSV restore file. After that, you create an installer object with that file, and whenever that installation is done, you can call virtual machine to start. You just wait patiently, all the things happening in the background, and after all this beautiful code, this is your welcome screen. This is right there in your macOS application, and you have a full-blown Mac machine booted into. Obviously, you have to configure it just like a new Mac. That's a side effect that I don't really like. I would expect that if you do this for virtualization, it would immediately boot into something that you can use, but apparently you have to configure it. And also the weird part here that Apple doesn't give you any APIs yet to do some kind of automation, how you can install, extra softwares. Like in a Docker file, you can specify, for example, that, I need this kind of applications, or maybe you have an Ansible thing that installs everything. Here you don't. So you really have to do everything manually, or you figure out a way to work around it, like attaching an external hard drive. Then there is a script that can always change, and then when the user logs in, you auto start that script that does everything. It's a bit difficult, but there are ways around it. And basically then you have your virtual machine. You can run it. For a basic machine, you need like 80 gigabyte free space. And then that also includes an Xcode, for example, if you want to use it for development or compilation related tasks. And then, you can come like, okay, but if I just have a basic Mac or whatever, how many virtual machines I can have? What can I store? It's just growing. If I install, what happens? And luckily, there is a feature in APFS. APFS is the Apple file system, the latest one that they use. And that has a copy on write mechanism. So when you copy a file, it basically makes a clone of it, where the original file stays at the place, and then the new one that you copied from it, then that just contains the diff between the old one and the new one, and some metadata to know where to go. So basically, if I have a Mac, so if I set up a virtual Mac now, I install Xcode and I do something with it, and I say, okay, this drive is complete, I'm happy with it. I make a copy on write copy about it, and I give that one to the virtual machine that basically reacts like a snapshotting solution. So you boot up your virtual machine from that copy. Everything that you do on the virtual machine now, it's saved in that new copy. And if you say like, I don't like it, you delete that copy, which is only just few megabyte or gigabyte, depend on what you did. And then you can still go back to the original one, which is the 80 gigabyte, and you can spin up a new machine and you can just do whatever you want with it. So you don't have to store hard copies of hard drives. So if you spin up 2 virtual machines, you don't need twice 80 gigabyte of hard drive, for example. Or like when you make a snapshot, for example, you don't have to save the whole hard drive because macOS does it for you if you use the copy on write logic what Apple introduced. There is one issue that I discovered, that if I run multiple virtual machines in parallel and they try to use the same hard drive copy, then it dies. So you cannot really write 2 diffs at the same time from the same hard drive image. It's really unhappy. Maybe I'm doing something wrong. Maybe this is not how it planned, but that doesn't really work. If I have 2 copies, then the snapshot thing works as expected. Something has to be investigated further. So what I would like to now show you, that the performance gain or losses if you use virtual machines compared to a physical machine, and what happens in the cloud. what you can see here, this is a commercial CDCI machine in the cloud. You just check out your code and let Fastlane, for example, build an iOS SDK for THEO player. And what you see here, this is benchmark scores for that machine. Yeah, you could argue that doesn't say anything, but at the end you will see the correlation with the time. So you can see that this machine, what we get from the cloud provider, it uses an Intel Core i7. Uses it. You don't know. It's a virtual machine. They can lie, whatever is there. It can be that even runs on a Windows computer or Linux computer, and it's just there. And as you see that the single core performance is pretty low, 800, and the multi-core performance is 2,400. It's like 4 times. Probably it's a 4-core machine. If you check now the real physical machine, an M1 MacBook Pro, which has 8 cores, and it's a basic setup basically, that you can see that already the single core performance is 2-3 times more than the other, and then the multi-core obviously sky high. And if you create a virtual machine on this physical computer, where you grant only 4 GB memory if you want, but you can grant 16 or as many as you wish, and you give it 4 cores, you can see that if I go back, that the physical machine single core performance is almost the same as the virtual machine's single core performance, and then you can see it even in the multi-core. So when you virtualize something, I don't know what kind of Blackmagic Apple does there, but you don't really use any performance. I try to look it up, what they do. There is no like a clear description what's happening, but you don't lose a lot of performance there. And then what this means when you really use these things in production, that as an example, I compiled the THEO Player SDK, iOS SDK project on these machines. If you build it on the physical machine, it takes 2 minutes. If you run 2 parallel processes on the physical machine, then it will take longer because you have 2 things running. It will take 3 minutes to compile the 2 SDKs at once. However, if you use the cloud solution, what we currently use, there it takes 9 to 11 minutes to compile the same SDK, which is a lot. And then if you spin up a virtual machine which has half of the performance of the original machine, then it will take 3 minutes 40 seconds. And the funny part is, if you run 2 copies of this machine, both of them start at the same time and both of them finish at the same time, all it takes 3 minutes 40 seconds, which is a big gain compared to what the cloud provides you. So then you can ask, maybe should I start my Mac as a VM service and then even earn some money, or just switch off all the cloud providers what I'm using, and what should I do? So currently the cloud CDCI that this is not really working. The cloud CDCI that we use now, we have an old plan where they charge you $100 per month for 2 parallel builds. That's like you could have 2 machines basically running non-stop in the cloud. But these are the slow machines which will do the SDK for 11 minutes, basically. And then, if you see the life, let's say in a projection in 3 years, how much you have to pay, then you end up $1,800 for a 3-year period for these 2 parallel executions, which is okay. It's not bad, I would say, but it's really slow. If you see their new pricing, what they provide, you don't have these plans anymore. What you need to buy is tokens, basically, and compare. Depend on which machine you choose. It can be an Intel-based M1 Mac machine or Linux or whatever. It's defined that this machine costs you 1 token per minute, the other one 2, and then if you go with an M1, that's 6 tokens per minute. And that also means if you would run that machine 24 hours, that's the amount of credit you would pay, and then they have a pricing table where it's end up that you have to pay $1,200 per month only for that one machine if you want to run it. So if you see it in a 3 years period, I don't think you want to see that number. However, if you decide that, oh yeah, if these are the cloud prices, maybe we should start building up our own in-house infrastructure, or do something hybrid, or rent some Macs in the cloud, and then we start doing some virtualization there, or we just use those ones as they are. What could happen? Then basically, if you buy the latest M2 Macs, what Apple provides today, then you can get a basic one for $600, or a pimped version, which is really good, for $1,300, and that's a one-time payment, and that machine is good for you for 3 years, and that's the whole cost what you spend on the machine. Obviously, not counting the maintenance, the development cost, and tooling, and the energy, and whatever. But I think compared to what the new pricing of that cloud thing would give you versus 600 or 1,300, that's a big difference, and worth probably experimenting with it. And then if the same physical hardware you spin up to virtual machines, then you cut the cost into half. There are other solutions on the market where they really just can rent a bare metal computer in the cloud. It just, yeah, like you would buy a Mac machine like this, and they just give you a network connection, and that's your computer. There is a service called Scaleway, where they charge you 11 cents per hour if you use that Mac. So if you see the projection for 3 years, then that's a pretty good deal. I would say you still have to configure everything, and you have to figure out what to do. But it could be that, yeah, I just build a virtual machine, I put it on that bare metal, and then you always have the setup you need. If you check the AWS pricing, they give you the same M1 machine with different plans. You have to commit for 3 years if you want to get some deductions. But there again, for a 3 years projection, this is what their website printed out: $12,000, or 9,000, or if you just decide, just need on demand whenever it runs. If you would go with that plan, which obviously you will not choose, then it's $17,000 for 3 years. So, yeah, I think it's something we have to look into. In general, companies have to look into. If you have money, you don't care, you go with nice cloud tools, and obviously they have their own benefits. So a lot of extra software, a lot of integration, everything you need is there. You just click, and then you are done. Meanwhile, if you build up your own system, it takes time, it takes maintenance, but at some point the company has to put the limits. Do I want to pay 30,000 per year or a 3 years projection, or I just, if you already have engineers who enjoy doing this, maybe just ask them to check it, things like that. But yeah, it's and also those prices. Yeah, if you work at Facebook or Google and you have to run these things non-stop in parallel, then that money is just multiplying continuously. And if you have a big engineering team, you could just we do it in house. So what are the limitations with this setup? As I mentioned, that there are no APIs yet where you can, for example, set up some automation when the machine boots up. You could work around it, but it's not nice. Apple, by the software license, limits you to run only 2 virtual machines on one single computer. And because right now this whole virtual machine integration on the Apple Silicon machines is really, they claim, it's part of the kernel and whatever. They can really restrict you on that level. So you cannot start a third one. It just was an exception that, hey, you are running already 2, so the third one is not allowed. Probably with some hacks here and there and booting the machine into some weird state, you could hack it around, but officially it's not supported. And because it's part of the legal agreement, probably they can come after you if you would build up your own M1 farm at home or something. And then what I mentioned with this whole copy on write issue, that if you do a lot of busy work, apparently it's not really supporting it, like compiling a TypeScript project and getting all the things around it. But maybe it was just me, so we have to look at it. Yeah. I shared you information about the virtualization framework. You can see all the APIs. You can read about copy on write on the second link. There's a nice video from the WWDC where they explain how to make virtual machines, what they do, how they work. You can set up a Mac version and a Linux version based on the video. It's pretty nice. And there's a sample project from Apple. They released it recently where they just build up for you an installation script in Swift and also another script where just you just run the machine. And it's really like, I don't know, 5 files and you have a complete virtual machine setup. So it's pretty easy to set it up compared to how it was, let's say, 2-3 years ago, where you really have to write C-level code and every little thing had to be configured, and at the end you have a big bunch of things where you don't even know what they do. So yeah, that's gonna be it. I hope you guys enjoyed it. A lot of numbers, a lot of virtualization. If you have questions, we can discuss it out. Thank you.